We're going to change the system of equation to matrix form and then solve it. So we're going to just take the coefficients. So the first coefficient is 2, the second one is 5, the next one is 1, and then the answer is negative 12. So this is our first row. Then our coefficient for the second equation are negative 1, 4, 3, and negative 4. And then our third equation has a 5x, no y, a negative 2z, and negative 13. So this is our matrix, and we're now going to do elementary row operation in order to change it. So what we are allowed to do is multiply columns, multiply rows by numbers, and we can add multiples of one row to another. We can also switch our rows around. Okay, so in order to eliminate our x value over here, we're going to use the first and second row. We're going to multiply the second row times 2. So we're going to do row 1 plus 2 times row 2, and we're going to put that back into row 2. So let's take row 1, which is 2, 5, 1, and negative 12. We're going to add to it 2 times row 2. So row 2 times 2, the negative 1 becomes a negative 2, the 4 becomes an 8, the 3 becomes a 6, and the negative 4 becomes a negative 8. Now I add my 2 rows, and I get a 0 over here. That's how I've chosen to multiply my row 2 by 2 in order to eliminate the x. 5 plus 8 is 13, 1 plus 6 is 7, negative 12 minus 8 is negative 20. Okay, so now I have my new matrix, 2, 5, 1, negative 12, and then I have 0, 13, 7, negative 20. And then my third row is untouched so far. Okay, so here's my new matrix. Now I'm trying to eliminate the x in my third row. So over here for my third row, I could either multiply the first row times 5 and multiply this times negative 2 and add the 2, but I'm actually going to use the second and the third row again just because it's going to be simpler. So I'm going to take my original one over here, multiply this row times 5, and then stick that into row 3. So I'm going to have 5 times row 2 plus row 3, and I'm going to stick that into row 3. So let's write this down. Let's multiply this times 5, which gives the x value negative 5. It makes my y value equal to 20. This one is, or the coefficient, this one is a coefficient of 15. This one is a coefficient of negative 20. Now I'm going to add the ones below to it. And when I add these two, I end up with a 0, 20, 13, and negative 33. So let's stick that into row 3, and I have a 2, 5, 1, negative 12, 0, 13, 7, negative 20, and 0, 20, 13, negative 33. Unfortunately, some of my numbers are getting a little big, but it's okay, we can handle it. So we're going to multiply this row times negative 20 and this row times 13 in order to eliminate it. So we're going to take negative 20 times row 2 plus 13 times row 3, and we're going to stick that into row 3. Okay, so negative 20 times this row, so obviously my first value is still 0. Negative 20 times 13 becomes negative 260. 7 times negative 20 becomes negative 140. And then negative 20 times negative 20 is positive 400. Okay, now I'm going to look at my third row and I'm going to multiply that times 13. So 13 times 20 again is 260. 13 times 0 is 0, so I can fill that in. 13 times 13 is 169. And then negative 33 times 13 is negative 429. Adding my two rows together, I have a 0 here, a 0 over here, I have a 29, and then I have a negative 29. So let's put it all together in matrix form. I just realized I went off the page over here, so let's go through this again. So my row 2 times negative 20, the 13 becomes a negative 260, the 7 becomes a negative 140, and the negative 20 becomes a positive 400. Row 3 times 13 is a 260 here, a 169 over here, and then the last value is a negative 429. When I add these two rows together, I already had eliminated my x. This eliminates my y. 169 minus 140 is 29, and 400 minus 429 is equal to negative 29. So I can now write down my matrix: 2, 5, 1, negative 12, 0, 13, 7, negative 20, and my last row is 0, 0, 29, negative 29. So I now have my triangular shape, which I can now back substitute in order to solve it. So this one stands for my z, so 29z is equal to negative 29. Well, when I divide by 29, that means my z is equal to negative 1. That's my first part of the solution. This is what I plug back into row 2 over here. So row 2, I have no x, but I have 13y plus 7z is equal to negative 20. Well, my z is equal to negative 1, so I have 13y plus 7 times negative 1 is minus 7 is equal to negative 20. Okay, now I'm going to add 7 on both sides. I have 13y is equal to negative 13. I divide by 13, and it looks like y is also equal to negative 1. Okay, now I've found my y, I've found my z. I'm going to plug both of those into equation 1. So my equation 1 is 2x plus 5y plus z is equal to negative 12. I'm plugging in my y, I'm plugging in my z. I have 2x plus 5 times negative 1 plus negative 1 is equal to negative 12. That is 12x minus 5 minus 1 is equal to negative 12. And over here I have 12x minus 6 is equal to negative 12. Add 6 on both sides and you get 2x is equal to negative 6. And we're almost done. We divide by 2 on both sides, and x is equal to negative 3. So the solution for our system is the point negative 3, negative 1, negative 1. So we started with our equation at the beginning, our system of equation. we changed it to matrix form. Then we did elementary row manipulation. We multiplied rows by certain numbers, we added them to other numbers, and then we simply changed our matrix to triangular form, and then we solved it. Tomorrow I will show you how to do this on the calculator. So on the calculator it becomes very, very simple, and we can easily solve a system of equation without having to do all these different transformations. So that's it.